Hello world, this is Chris with Elevations. Today we're going to do a quick little video on an introduction of the VR VEX world. And this video is specially made for Jessica. Jessica is interested in getting into programming, and this is a really good opportunity just to take a look at the environment and utilize this free resource that has a lot of powerful capabilities as well as explaining the code behind what actually is happening. So I've shown in the previous video some of an overview of how this system works, and I'm going to dive into that a little bit as well today, along with some of the actual code that is running behind the scenes when you're actually doing this block-based program. So if you look here where it says when started, this is a blocks-based side of things. So that gives you the capability of doing drag and drop programming. So essentially you're taking the more difficult part of actually typing out the proper code and syntax that you see over here on the right hand side. You take that out of the equation and you start working on just learning the basics of how looping and some of the stuff works, and that's what I'm going to be focusing on today. So as you see here, when started, it's going to run whatever is below it. Now for the sake of it, let's look over here on the code side. The very first thing that happens on the top of this code when it runs is it just sets a variable equals 0. So that's the my variable. And it does this by default, but it's a beneficial aspect and something you can add more variables if you wish to play with. But in this video, we're not actually going to be utilizing any variables. Now notice right here where it says def, when started. This is actually a function that's going to be operating the actual code that will be dropping with these blocks here on the left-hand side. So when the program first runs, it's actually going to be skipping line 3, which as you can see as I close this down, this line 3 encompasses everything within this function. And you can notice where right here where it says def and then when started, this function, everything underneath it that's included in this function is indented. Now I will typically do that with a tab base as opposed to a space bar, but some people like to do space. That's a continuous argument of spaces versus tabs, but I like the cleanliness of tabs and I will always do tabs. So since we are skipping this function right off the bat, the first thing that's actually going to be executed after the variable is initialized is line 7. Line 7 is this VR underscore thread, and then notice the open parenthesis, when underscore started, 1, open, close, close. So one thing to keep in mind every time you're actually writing code is every time you have an open parenthesis, you must have a close. So notice this open right here, and then it's highlighting here for you the close that corresponds with this open. And then you have the when started, open, close. Now notice when I highlight this, it also references the function that's going to be called. So when VR underscore thread when started is actually run, it's calling back to this function, as you can see line 3, def when underscore started 1, open, close. This function right here is where everything is going to happen. Now, if I wanted to, and we will do this down the road, and you might have seen in some of my previous Python programming classes, you can actually pass variables from the program itself to and from functions, and that's what would go inside of this parenthesis. Since we're not actually passing it anything, say if I wanted to just say my variable 1 equals 1, then I would put my variable 1 inside this parenthesis, but right now we're in record only mode, so that's not going to be showing, or we're in read-only mode, so that's not going to be showing if I actually type something there. But I want you to watch that code as I drag and drop. The first thing I'm going to do when I start this program, and what I want my robot to do in the virtual world, is I want to have a simple program that's going to allow me to drive in a square. To continuously drive in a square, I want to have, as opposed to having a whole bunch of lines and basically infinity lines going all the way down, I can make a forever loop. By doing a forever loop, whatever I put inside that loop, as the name describes, will loop forever. So you have the option of repeating X amount of times or simply doing a forever loop. Since I said I want to do forever, I'm going to drag this forever block. As I drop this underneath when started, keep an eye on what happens over on the code. I'm dropping it. Now we have this extra section inside of our function. While true, colon, and then you see another indent. Something to keep in mind with a forever loop, true always equals true. You can say add extra arguments into your loop, so it'll exit that loop if another aspect becomes true or false, or let's say x equals x, or while x is less than or equal to 5, it'll loop a certain amount of times until x then equals 5. So there's lots of different stuff you can do with looping to make a program do something in a certain period of time or a number of times. But since I'm doing a forever loop, we simply are going to be saying while true, because true is always true. So the first thing I'm going to do, because we're actually starting the bottom left-hand corner of the playground, and I'll open up playground here so everybody can see what this looks like. Jessica, hopefully you're following along here and this hasn't been too complex for you already. It is quite simple, and then the nice part about YouTube is you could just rewind it and replay what I've already said. It'll make your life pleasant. Okay, notice my little simulated robot here in the bottom left-hand corner of my playground. So the playground, that is a term I'll be using a few times. That essentially just references this large square block that we have to work our robot in or to play around in. So our playground here you see is a collection of multiple different boxes or squares. What I want to do, just for the sake of this video and this exercise, is to drive forward a certain distance, and then I want to turn right 90 degrees, and I want to drive forward again. And then I want to turn right 90 degrees and drive forward again, turn right 90 degrees and drive forward again, and then turn right. So if you keep track there with those multiple 90-degree turns, I will then be in my current location, which in turn will also be my final location. Because we're working in this virtualized environment entirely inside this computer, we don't have to worry about environmental variables that you would in the real world. In the real world, if you're actually setting up a robot or doing something in the real world, you'll have to worry about wheel slippage if you have a wheel issue, if you have a drivetrain issue, if you have an issue on whatever platform or playground you're actually physically working on. There's a lot of different variables that come into play when you're actually doing something with a physical robot. That's one thing that's really nice about this virtualized playground is it will do exactly what you tell it to do. So I'm going to close this playground and we will work on the code to make that happen, and we'll do step by step. So the first thing I want to do inside my forever loop is I want to drive forward. Notice here on the left-hand side you have all these different blocks. You have these color code circles that will give you different sections inside of that. So right here on the top left you see drivetrain, magnet, looks, control. Control is some of my logic that I'm doing right now, which is where this forever loop came from. Now you can actually just click drivetrain, or from this orangish part you can scroll up and actually get to where your driving section's at. Since I want to drive forward for a set period or a set distance, I'm going to grab my drive forward for 200 millimeter. That will give me the direct control of what direction I want to go to and my distance. Now here we have the option of choosing forward and reverse. We also have the option of increasing or decreasing our actual distance, as well as the millimeter versus inches. Since the playground, I do believe, is set up entirely based on millimeters, I'm going to keep it in millimeters. Now for the sake of this, I want to see how far it's going to go when it goes 200 millimeters, because I do not recall exactly what that is. So the next thing I'm going to do, just so I can see where it stops, is just put a turn right 90 degrees. I believe there might be a weight option in here as well. Yeah, so we have a weight control, so I can put that right between it. So once it hits that 200 millimeters, it'll stop and hold still for 1 second. Now let's take a look back over here at this code and see what we see. So while true, inside of our forever loop, we have the drivetrain.drive underscore 4. This section is essentially part of the coding built into this virtualized robot. So when you're doing coding, you can pull in a lot of different types of libraries that you can then make reference to, and that's where some of this statements prior to what I actually want to do will come into play. Now within this online virtualized environment, everything is nice and simplified where it will autofill that stuff out for you. But if you want to do this directly via only code, you have to type this stuff out. You can change what you need to type, or what you need to type may change based on what library you're using, and all kinds of different variables when you actually start doing stuff where you're building a robot with a Raspberry Pi or a lot of other different types of things. But again, the nice simplicity of this online system, it can autofill that out for you, and the library is very simple. So again, coming back here, we have this drivetrain dot drive underscore 4. So that's basically saying how far I want to go and then my direction. What you see here are the parameters of this command. The first parameter there is forward because I'm going forward. And you can see in reference this forward right here is the same as my forward right here. Now if I hit this drop down and change that to reverse, then my reverse right here. So again, these are the parameters inside these parentheses. These commands have different parameters inside the parentheses. The next parameter is my 200. So that's my for 200. If I change that to 300, it'll change here in this code as well. And then the third parameter here and the final parameter for this type of command is my measurement type. So I can change this to millimeters, I can change this to inches. And again, we're going to keep that in millimeters. Then the next, as you saw, I just did this drop here, wait 1 second. This is where this wait 1 second comes into play. And then we have another one with the same type of library call where you have the drivetrain dot, and most of everything based on the drivetrain or directional control will have a drivetrain dot something. That's part of the actual Python library that it's calling from. And for the sake of doing the programming on the blocks itself, it doesn't entirely matter. So again, with this drivetrain dot turn underscore 4, that relates back to this other section of blue that we see right here. This turn 4 will relate back to the same command of this block and this code. Now again, you can see within these parentheses we have 3 separate arguments. We're wanting to turn to the right, we're wanting to turn 90, and we're choosing in degrees. You can choose a lot of other different types of things here, and it'll add more arguments along that, but we want to just stick with a 90-degree simple turn. And then part of what's automatically added with this block here is this forever loop. At the end of this forever loop, we have a wait for the 5 milliseconds. So it's a very, very short period, but it will be waiting for 5 milliseconds. We can add another wait there before it takes off again, but we're not going to do that. So for the sake of it, let's just take a look and see how far 200 millimeters actually will be. And then the turning right for 90 degrees should be an exact right turn because we're in that virtualized environment. Now I want you to think about this. Since I am wanting to go all the way back to my starting position and then just continue on this square, if I wanted to, I could do the exact same command right after my turn right, which means I could do another drive forward. I could take a drive forward and throw it back over there, and I'll just do that for the sake of visualizing it. I can throw another drive forward right here. However, since we are in a forever loop, I have no need to have another drive forward after my turn right, because as soon as it hits that bottom orange section of the forever loop, it will then follow all the way back up to the top of the forever loop. From this point, it'll jump back over here and continue down again. So it will do forward to 200 millimeters, wait 1 second, right turn. So in essence, to make a square, and if everything works out right, to make a square, this is all the code that I actually need to make my robot run in a square. So let's open up the playground and actually see what it does. Okay, as this loads, I should be able to hit play, and then it will simply drive forward by that 200 millimeter point, wait 1 second, turn right 90 degrees, and then continue on my loop. So you see here in the bottom left hand corner, here is my virtualized robot. Let's execute this code and see what happens. You can see right here, the green section, it highlights what's actually happening. And you can see that 200 millimeter is based on just this block. Now since 200 millimeters, I'm going to imagine, is actually the size of this block. Therefore, it's only going 1 block at a time. Now I want you to notice how this executes, and we're just going to keep it in this nice small block so we can see how the green highlighting is executing on the block. You can keep an eye on what is actually executing and the robot and the code. You can see this loop executing in real time. Since nothing is ever telling it to stop, once it makes it to the bottom of the forever loop, all it does is jump all the way back up to the top and then continue it on back down. Now coming over to the actual physical code itself, while true is the same as this forever loop in the orange. It hits the drivetrain drive forward, then it does the 1 second count, then it continues to turn right, and then it jumps all the way back up to the top of the forever loop. That is all it really takes to do a forever loop with a 90-degree turn. Now for the sake of making this square a little bit larger, I'm going to stop this. And I'm going to increase this. Let's say if we've got 200, I'm going to reset so we start back at the start. If 200 is one block, 400 should be two blocks, and then 800 should be four. So let's go ahead and change this to make it a 4-block system. And then notice my arguments on my actual code here have also changed to 800. So I'm going forward 800 millimeters, and then it will continue with that weight, and then it'll do another 90-degree. Executing that code, it'll essentially do the exact same thing in a larger block pattern. So you can see as it executes forward, it highlights the green. We go 1, 2, 3, 4 from the starting location. Turns 90 degrees, goes back 4 with that 800 millimeter. It's going to turn 90 degrees, goes back 4, and we should hit this bottom left-hand corner, and then it's going to turn back to the right, and we're going to continue on this loop. So that's a forever loop, and that's going to happen forever until I hit stop. So this is a really good example just to kind of keep an eye on what the block code is doing and then what the actual text is doing for you behind the scenes. We can expand on this, and I might do that in another video, but this video is essentially just for the forever loop, just so Jessica can get an eye on how this actually works. My name is Chris with Elevations. I hope you learned something. Thank you for watching. Please like and subscribe below.